Hello everyone, we are going to learn chemical bonding. So for this video, we're going to focus on ionic bonding. Okay, so we're going to define chemical bonding and explain why most atoms form chemical bonds, why they want to stay together, and then we're going to describe ionic bonding. First of all, everything in this world is composed of elements. We can find all the detail of all the elements in the periodic table. There are totally 118 type of elements. And with all of those elements, they can combine together to make compounds. A compound is a chemical that contains more than one type of atoms. They are not just simply stay together, they are chemically bonded together. So like water contains hydrogen, oxygen. Table salt contains sodium and chloride. They are not just simply mixed up. They forms a new compound by through chemical bonding. We are going to figure out how can they bond together. Okay, how do elements combine to make compounds? So basically, it's because of attraction. What kind of attraction are between those atoms? When atoms get closer enough, each atom's outer energy. Electrons in the outer energy level, which are we call them valence electrons, those valence electrons are going to have a strongly attraction between those electrons with the nuclei of the surrounding atoms. So the outer electrons, the valence electrons, have not only attract to their own nucleus, also have an attraction between the nucleus of other atoms, which cause a bonding. Okay, here's what a chemical bonding is. Please write this down. A chemical bond, a bond means connection, right? A bond is a mutual electrical attraction. It's basically attraction between positive and negative. So the positive is the nucleus, contains proton in there, and the valence electrons. The valence electrons are of different atoms. This time is talking about the nucleus of one atom and the valence electrons of another atom. There's an attraction between those and binds the atoms together, which we call a chemical bonding. Please write this down. And atoms form compounds by different ways. Okay, one is gaining or losing electron, the other way is sharing electrons. We're going to learn both for this couple of days. So first of all, we're going to focus on gaining or losing electron, which we call ionic bonds. Okay, so let's go have a quick review of how ions are formed. For example, sodium is number 11 in the periodic table. It has 11 protons. For a neutral atom, it also has 11 electrons. We know that electrons are arranged in a 2-8-8 rule, right? And the first energy level 2, second energy level 8, and have one more to go to the third energy level. So for a neutral atom, 11 protons, 11 electrons has no charge. But as we said, all atoms want to be stable and they want to have a full valence electron arrangement. So sodium would prefer to give away this one. Once it gave away one, it becomes to two energy levels. The first energy level is 2, the second one is 8, and there's no third level anymore because this one is gave away. Once it gave away one, it becomes to 10 electrons left. So still have 11 protons, 10 electrons. This time sodium become to sodium ion. And the charge for this sodium ion is 11 positive, subtract 10 negative, so it become to positive 1 charge. And people write the symbol like this. Write the sodium first and then write the positive sign on the top right corner. Okay, that's we call a sodium ion. The charge of this sodium ion is positive 1. Okay, now let's look at another example of chlorine. Chlorine is number 17 in the periodic table, which means it has 17 protons. So when we arrange the electrons, again, we first energy level 2, second one has 8, and the 7 go to the third level. So again, chlorine also want to have 4 valence electrons. So it want to have 8 valence electrons in the third energy level. It would just prefer to gain another one. Okay, so once it gain one, it become to still have 17 protons, 18 electrons. So this time it has one more negative. So it become to a -1 charge. How do we get the -117 subtract by 18? Okay, -1 charge. And we write the symbol as Cl, which is the symbol for chlorine, and put a negative sign on the top right corner. Because it's a 1, people normally don't bother to write the 1. When you see a negative sign, it means -1. Okay, so now let's have a look. More slides. I don't know why it's not showing. Okay, so basically, when sodium met chlorine, sodium is desperate to lose an electron. It want to give the one away, and the chlorine really wants to get one. So when they met each other, they love each other. Okay, sodium ion and chlorine ion is the perfect match in heaven. This is what happened when sodium meets chlorine atom. Okay, sodium wants to give away, chlorine wants to receive one, so they love each other, they want to stay together. Okay, sodium gave away its electron, and the chlorine received this one. This does not belong to sodium anymore. This now belong to chlorine. Okay, sodium become to a +1 ion, and chlorine become to a -1 ion. Positive and negative love each other, they attract each other. Okay, so we call this process electron transfer. It's a transferring of electron. Sodium gave away, chlorine receive, and this one belong to chlorine now. It's not sodium's anymore. Okay, so now it forms a chemical compound, sodium chloride, right? And they stay together forever. Okay, so this is positive, negative, they attract each other. Okay, this is how chemical. So first, let's write down what is a chemical bond. Chemical bond is talking about the attraction between atoms that enables the formation of chemical compounds. Chemical bonding is basically positive and negative attraction between atoms. Okay, and type 1 bond, we call it ionic bonds. It's basically between ions. It's the forces of attraction that bind positive and negative charged ions together. We call them ionic bonds. Okay. Okay, so ionic bonds, why ionic bonds form? Again, if you remember, metals are on the left side of the periodic table, they would prefer to give away electron to form positive ion. And non-metals are on the right side of the periodic table, they want to receive more electrons to have the same arrangement of the noble gases, so they prefer to receive electron to become the negative ion. So ionic bonds always form between a metal and a non-metal, like sodium and the chloride. It's the perfect match. Okay. One more thing about ionic bonds is it's a very strong bond. So for example, sodium and the chlorine, and around the sodium, let's look at this one. Around this sodium, it has one, two, three, four chlorine. It's flat, right? Think about three-dimensional. When it's three-dimensional, there's one chlorine outside of sodium, one chlorine inside of sodium, like inside this computer. So there are actually 6 chlorine ions, negative ions around one sodium positive ion. So all this sodium positive ion has attraction with all 6 chlorine ions. Think about three-dimensional, okay? So normally strong solid, it forms solid crystals. So people call those salt or crystals. Okay, ionic compounds are also called salts or crystals. They are strong attraction between positive and negative ions. They have very strong attraction, so normally they form solid. Okay, that's everything you need to know about ionic bonding. We're going to review it during the live class.